Guys, we're done solving just linear inequalities and graphing them. Now we're going to move on to the next step. A little bit more difficult, but we're going to try to graph systems of linear inequalities. So 2 or more inequalities, we're going to graph them at the same time and try to find the solutions. And so by the end of this lesson, you should be able to answer the question of how do you graph systems of linear inequalities with a question mark at the end and not a period, because that's grammatically correct. But I'm a math teacher and I make those mistakes often. So let's just go through the steps on graphing systems of linear inequalities. Step 1 is to get both equations in, just like before, y equals mx plus b form, otherwise known as the slope-intercept form. That's our first step for graphing those. So right now, let's just go below here. I got these two equations right here. I want to get them in y equals mx plus b form. So let's start with this one. Let's get this one in y equals mx plus b form. I got x plus y is less than or equal to 2. X plus y is less than or equal to 2. I'm going to subtract x from both sides, subtract x, and so I have y is less than or equal to negative x plus 2. I didn't have to swap this around because I never divided by a negative number. So that's that one. Let's move on and do this one. Get this one in y equals mx plus b form. So I'll do this one over here, and then I can rewrite it over here. I'll do it over here, I'll rewrite it over here. So I'm going to subtract x from both sides, subtract x. So I got negative 3y is greater than or equal to negative x plus 6. And at this point, I'm going to divide everything by negative 3. And when you heard that, you should have said, Mr. Benson, you better not forget to flip the inequality sign. I'm sure you all said that, right? So we're going to have to flip the inequality sign because we divide by negative 3, so I'll just start that at the beginning. Now it's less than or equal to instead of greater than or equal to. I got y, negative divided by negative is a positive, and this is kind of the same as 1/3, right? 1/3 x. And 6 divided by 3 is negative 2. So that's my other equation right there. So I got my two equations going for me. I'll put this one right up here. So I got y is less than or equal to 1/3 x minus 2. So I'm going to graph these two equations right here. And my solution, well, we'll see what happens. Let's follow the rules. Okay. So again, we graph one line, and we use a dashed line for less than or greater than. Let's use a different color. Less than or greater than, and use a solid line for less than or equal to or greater than or equal to. So let's dash, choose a point C. Okay, so let's graph one line. Just like I said, I'm going to clear this out just to make my life a little bit easier over here. Nope, no, don't want to do that. I don't want to do that. That was a mistake, everyone. Okay, so no, don't want to do that. Here we go. So let's graph the purple line first. So y is less than negative x plus 2. So we're going to go up to positive 2 because that's my y-intercept. And my slope is negative x. So I got a bunch of dots going down like that. I got a negative 1 slope like that. And now I got to pick a point that I'm going to plug into this equation and see if it's true. Mr. Benson told you a long time ago, pick the point 0, 0, unless it's on a line. That's the easiest point to plug into this. So I'm going to pick that point. If it turns out to be true, I'm going to shade below this solid line. Remember, it's a solid line. How do we know that? Because this says equal to. We're going to shade below if it's true, above it's not true. So let's see what happens to this. We'll bring this over here. I got y is less than or equal to negative x plus 2. So I got 0 when I plug this point into it is less than or equal to negative 0 plus 2. I got 0 is less than or equal to 2. Is this true? Yes, you're right. It is true. So therefore, we will shade down here. I'm just going to draw arrows just to remind me. Because we're doing systems, sometimes it's nice to just draw arrows so it doesn't get too crazy. What's going on here? So there are my arrows that will remind me where to shade there. Okay? Now, let's do the next line. I'm pretty sure that's the next step in the order. Let's double check it. Choose a point, see which side of the line is shaded. Graph the inequality line. Graph the second line right there. Choose a point, see which side to shade. Yep, that's part 5. And then your solutions are what is double shaded. Oh, let's put that in. Double. Or, in other words, think of what's overlapping. Where is it overlapping? So we got this one going down. Let's start to graph the red line right here. So the red line starts at -2 and has a slope of 1/3. So you go up 1 over 3. Up 1 over 3. And we could go down 1 over 3. Down 1 over 3 this way. And is it a solid line? You bet it is, because it's got the equal sign right under there. So we've got a solid line right there. Draw a nice solid line. And there we go. There we go. Okay. And now we got to figure out where we shade. So again, I'm going to pick the point 0, 0. I'm going to put it in there. I'm going to plug it into this equation. So I got y. I'm going to plug in the equation y is 1/3 x minus 2. So I got 0 is less than 1/3 times 0 minus 2. So I got 0 is less than, oh, that should be 2. Less than -2. Is 0 less than -2? No, that's false. Because that's false, we don't shade on this side. We shade on the other side, so we shade below it. Okay, we shade on the side that did not have the dot we chose because it's false. So we're going to shade down this way. Now remember, if this turned out to be true when we plugged it into this equation, if this turned out to be true, then we shade where the dot was on that side. Okay? So there, we know we're shading both of these. And what we're looking for is where it's double shaded, or think of it as overlapped. Where are the shadings overlapped? Let's see if I have the shading. Oh, it doesn't have it there for me. I wish it did. Let's see if I go back here, if I can move these things around. Nope, does it? Wait, what is that? Okay, so let's, oh, I'm sorry guys. I feel bad about this. Can I use these? No, that would be ridiculous. So, where is it overlapped? Well, let's just think this through. Okay, I'll use the yellow because yellow is kind of nice. We got to shade below this line, so we can't shade up in this area, and we got to shade below this line, so we can't shade up in this area right here. So the overlapped area would be right in here, right there. This is the overlapped area. That's the double shaded. And so what this means is any point in this yellow region that I'm drawing these long lines in, any point in here, I could put into either of these two equations, and it would turn out to be true. It satisfies both of those equations, okay? If I picked a point in here, it would satisfy the red equation only. If I put a point in this area, it would satisfy the purple equation only. But anywhere in this checkered boxed yellow area would satisfy both those equations. And so this is your solution to this system of linear inequalities.